Okay, I think we can go ahead and get started. So our question of the day last time was the classic GIF debate, and we seem to be fairly split. It was kind of interesting. So maybe it's a little bit like Democrats and Republicans in the country as a whole. So that was an interesting result. I wanted to say just a few things briefly. So I had mentioned that we would normally be having a midterm coming up at the end of next week. We're not going to do a midterm, but we've decided instead that we're going to take a week off from programming assignments. So I have posted a new assignment today. So there is a 5th programming assignment that's due next Tuesday that I want you to work on. But then there isn't going to be a new assignment that goes out next week. We won't pass out a new assignment until 2 weeks from today. There'll be a new assignment, so you get a little bit of a break. It also gives us a chance to kind of catch our breath and reflect on the things that we've been doing. And that's particularly helpful in Chapter 5, because Chapter 5 has a lot of introduction of thinking about program logic. And so that's something that's going to be very important. We normally are covering this in terms of upcoming midterm questions, but so instead, we'll be doing it anyway, though, because this is important things to understand, and it's kind of important that we spend some time doing this before we start hitting the programs that come after, because those last few homeworks in the course are challenging. The TAs in section next week are kind of planning things that they want to do to give you a bit of a break, but also we're trying to include some opportunities to be thinking about this program logic, but also debugging issues. So there's an engagement activity tomorrow that's been announced on debugging. That would be a great thing. We see students struggling with this, and so this is, you're reaching a point where the programs are complicated enough that it's worth it for us to try to spend some time trying to give you some tips for debugging. I've had very interesting visitors to my office hours. I encourage you to come if you're interested. People sometimes just come and chat with me about how they're feeling about the course. I think if we're doing our job well, then a lot of you are kind of feeling a little bit like we're pushing you every week. That's how you learn, for us to kind of push you a little bit every week. But we're trying not to push you so hard that you fall over or something. So, and I think that we give you tons of resources to help you through this process. You're probably learning a lot in doing it. One of the questions that I'll sometimes ask people is, people are like, but each new program is hard for me. Isn't that a bad sign? Well, I think the better thing to ask is, what if I asked you to go back to homework 2 at this point? I bet you find homework 2 pretty easy at this point compared to what it was when you first did homework 2. So I think sometimes you don't always realize how much you're actually learning as you're going through. So I'd encourage you to stick with it. We are trying to push you, just not too much. And we do throw lots of resources at you. And I have noticed that kind of different students are not everybody's watching the lectures. Maybe about half the people are watching them in a timely manner. Those of you who are, that's great. I think it's really, really important to keep up with lectures. It's really important to participate in section, and keeping up with the homework is also kind of the key thing to keeping on pace for the course. So, hey, stop by and tell me about things if you're interested. I've also had some people who come by and have told me how surprised they are that they're enjoying the course more than they thought they would. And some people who were, in effect, novices, that hadn't really done a whole lot beforehand, are telling me that it's working out well for them. Anyway, I encourage you keep coming to lecture. I think it's very helpful, and I'm doing my best in the lectures to give you really useful material that gets you ready. Along those lines, let me mention, I think I told you a wrong thing at the end of the Monday lecture. So we did this Zune bug thing, and I said we'd talk about it in the next lecture. Well, I want to spend more time on that than I have available to me today. I'd rather prioritize today's lecture on getting you ready for homework 5. So that's what we're going to do. I am going to talk about the Zune bug. It's actually going to be next Monday when we have time to do it more slowly and carefully and talk about program logic. That's in Monday's lecture. So we will get back to the Zune bug, but that's not today. What I want to do today, I have a few miscellaneous things and then a couple of sample programs that I want to do with you. So let me begin I've just kind of put some lines of code here that I want to use in the interactions pane, because I want to talk about strings for a little bit. You're going to be using strings in your next assignment, and so I wanted to spend a little bit of time talking about some issues that you'll have to deal with in the homework assignment. I've already talked about this in last Friday's lecture, but I'm reminding you about it. We're doing it a little more carefully just to make sure that you're ready to do what you need to do in the homework assignment. So look, I've set up some different strings here. I set up a variable S1 that's referring to the string Washington, and then I set up Washington as strings and concatenated them together to make a string 4, and then there's a string 5 that kind of has the Washington but in a weird case, upper and lower case letters. So let me show you some things. So, I mentioned this idea in Friday's lecture with the say cheese example that we have, that you'll notice that S1 is storing the text Washington and S4 is storing the text Washington. Same sequence of characters. So you'd think that if I said, is S1 equal to S4, you'd think Java would say that's true. Well, it's not true. It's false. Well, why is it false? Well, it's because I have two different string objects, each of which are storing that sequence of characters. And I pointed out that JGrasp uses object numbers here. That's object number 184. This is object number 194. So it's two different string objects that each store that sequence of characters, Washington. So there was an alternative. So there was a slide I showed you. This is a slide this is last Friday's slide deck, so you could kind of go back to that if you need it. String testing methods. And there was a method called equals. So this is a case where we got to treat strings like an object and say, hey, S1, I'm going to use the dot notation to ask you a question. Are you equals to the S4 string? So I ask S1 to compare itself to S4 and tell me if it's equal, and it says true. I could just as well have asked S4, hey, are you equals to S1? And the answer will be true. There's a requirement for equals methods, a contract for equals, that it's supposed to be symmetric. So it shouldn't matter which one of these objects we ask, whether it's equal to the other one. We should get the same answer either way. That was the dot equals method. And I think I didn't mention this on Friday's lecture. I usually am better about doing this, but sometimes I mention things to people to make a note of. I sometimes talk about it as triple circling in your notes or something. I try to point out things that are really, really important to remember, and this is one that's really, really important to remember. Never, 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 never do an equals comparison on strings. So just don't do this. If there's strings, never, never, never use equals. Always use dot equals. In every case, for every program we'd ask you to write, and if we were doing exams, things we'd have you do on exams, get in the habit. Always do dot equals. Always, always, always. Well, there's other methods, though, that are here that I wanted to talk about a little bit. So there's like a starts with method and an ends with method. So I can come over here and I can say, hey, S1, do you starts with wash? Do you begin with W-A-S-H? And it'll say, yeah, I begin with wash. And I could say to S1, do you ends with ton? Do you end with T-O-N? And it would say yes. So you can ask strings whether they start with something or they end with something. So that's kind of a useful thing to be able to do. If I ask S1 if it dot equals S5, so now I'm using dot equals like I'm supposed to, but notice that, the S1 string was Washington in all lowercase letters, and S5 has the Washington in mixed case letters. They're not all lowercase letters. And I think you probably can guess what this is going to do. It's going to say false. That is not true. These don't store the same sequence of characters because of the capitalization, because of different, upper and lower case sequences of letters. Well, I wanted to mention a programmer's trick. This is something that you might use in your homework assignment. Kind of depends upon how you approach the problem, but it might be that you'll want to do something like this. We can ask S1 to give us an uppercase version of itself. So I can kind of get the uppercase version of S1, and I can ask S5 to give us the uppercase version of S5. And notice how those things will match. This sequence of letters is the same as this sequence of letters. So if you turn it into a standard case, all uppercase, then they're going to match. I could equally as well have turned them into all lowercase, but S1 was already like that, so I thought this was a better way of showing you. Either way would work though. So these are the uppercase versions. Notice up here that S1 is unchanged and S5 is unchanged. I pointed this out on Friday, that these methods, it was on a previous slide, but they return a new string. So that's why it's not actually changing S1 and S5. So how would we, if we wanted to do a comparison that kind of told us whether these things are equal when you ignore the case issue, a way to do it is to kind of ask whether this uppercased version of S1 matches this uppercased version of S5. But calling the method is not changing S1 or changing S5. We haven't converted them to uppercase. I mean, we could do that. I showed you on Friday. You could say something like S1 equals S1, then 2 uppercase. But there's another way to do it. We kind of want to have this string compare itself to this string with a dot equals comparison. So let me kind of show you that. So how did we get the first string? We got it by asking for S1.2 uppercase. So I'm going to have S1.2 uppercase. That gets me the uppercased version of S1. And I'm going to ask whether it equals the other string, which I got by doing S5.2 uppercase. So I'm just I'm doing a call on equals that's a little more complicated, but only because I'm getting a string by a call on uppercase here, and I'm getting a string by a call on uppercase here, but I'm asking those two uppercased versions to do an equals comparison. And this ends up returning true. So that would be a way of figuring out that these things match, even with the difference in case. There may be times when you're told to ignore case. You are in homework 5, so this is something you're going to want to be dealing with. Sometimes the Java class libraries are nice to us, so like here it gave us something called equals ignore case. That's interesting. So I could ask S1 whether it equals ignore case S5, and it says true. So, I mean, that's an easier way of doing it. Then you don't have to convert into the uppercase. So that's kind of a nice method to have available to you. But there isn't always an ignore case version of things. Like there isn't a starts with ignore case or ends with ignore case or contains ignore case. So there's not always an ignore case version of things. But, when it's there, that's a nice thing to be able to use. One of the things that happens with this homework 5 is that often students will kind of ask a message to the message board where they say something like, I was going to use this string method and this string method and this string method, and together those 3 string methods are going to allow me to do what I need to do. Is that okay? Am I going to lose points if I use those 3 particular string methods? And we don't allow messages like that to be posted publicly on the message board because you're telling other students in the class that this is a way to solve the problem. That's what you figured out. So we don't want to give away, what you figured out. So let me just try to head it off in advance by telling you, now that we've covered the string class, you can use everything in the string class. All of those things are available to you to use. Now, we don't always tell you in advance whether it's a wise choice. Sometimes you do things that are not particularly elegant. We might be unhappy about that, but we don't tell you in advance about that anyway. But in terms of nothing is forbidden in the string class. All of these things are available to you, and I think it's actually rather interesting that there are different ways to solve it. So different people are going to solve it in different ways, and that's a good thing, not a bad thing. So, figure out what combination of string methods you want to use to solve the problem. Other people might do it in a different way, and that's just fine. There isn't necessarily a right way of doing it. There's lots of good ways of doing it. So figure out your own way of doing it. You have permission to use string methods, anything that's in the string class now that we've covered it. Okay. I want to then switch gears. I wanted to talk about. Actually, before we do that, let me end my little interactions here. So I want to talk to you about, there's something that we're talking about today in the lecture. We're talking about a class that's known as random, the random class. This is a slide from today's slide deck. Random object generates pseudo-random numbers. The reason we say pseudo is that this random object that we're going to use uses an algorithm. I mean, algorithms by their nature are completely predictable. I mean, when the computer executes an algorithm, it's doing a very particular task. So randomness is a challenge for us because with computers, with algorithms, we don't have randomness. So there's a lot that's been written. Don Knuth has many, many pages written about how to simulate randomness, how to make it seem like it's random. And so there's something called the random class that allows us to be able to do computations involving these what we would call pseudo-random numbers. The slide mentioned that I have to import java.util.star in order to be able to have a random object. And now I'm going to say random r equals a new random object. So I'm constructing a random object. I'm using variable name r. I could call it rand. Some people say random rand. That's not a bad name either. It's not such a bad thing to use a simple name either, like we did with graphics G. Random r. It's not such a bad idea. So there's various methods that are available to us. So you'll notice that there's a method called nextInt. So I can say to the random object, hey, random object, give me an int, a random int. And it gives me that. And I say, give me another one, give me another one, give me another one. You'll notice some of them are negative, some of them are positive. It's in the full range of int, the full range of possible int values, including the negatives. And so if you want to generate a sequence of pseudo-random ints, you can say r.nextInt. We don't use that very often. We don't use that version very often. We tend to use this version here where we give it a number. Marty describes it as a max. I want to describe it as a slightly different thing, which is that when you call nextInt, the thing to be thinking about what to put inside parentheses is to think about how many different possible choices there are. How many different possibilities do you want it to consider? And so suppose that there were 5 different things. Excuse me, that's not what I wanted to do. We're going to do that in a little bit. Suppose that I wanted to have 10 different numbers. So if I say, 10 different possibilities, I can ask for a nextInt with 10 different possibilities, and it picked a 5. Marty shows that when you give it a max like that, it picks numbers between 0 and max minus 1. If 0 is a possibility, then obviously it can't go all the way up to max. So this should be giving us numbers between 0 and 9. But we shouldn't actually get a 10. I mean, we can look at a few. There's a 0, so you can see that it's getting some zeros. If we keep going, eventually we'll see a 9. Anyway, if we kept going, we'd see a 9, but we'd never see a 10. So you tell it in the parentheses how many different possibilities, how many possible numbers to consider. Well, suppose that instead of the numbers 0 through 9, you wanted 1 through 10. So often there's kind of a change. We don't want it quite what they're giving, like 0 to 9. We might want 1 to 10. And what we tend to do in a case like that is to do something like this, say to add 1 to it. So that shifts the 0 to 9 range up by 1, so it gives us 1 through 10. I mean, you might think that you could do 11, but that's not right, because now it's like giving you 11 different possible values, 0 through 10. So no, the 10 different possibilities, but we add a 1 to kind of shift the range. And I don't know if we're going to see a 10 at all in here. We won't see a 0. Oh, there was a 10. Okay, so you kind of got a chance to see that. All right, so that was just a little bit of intro to the random object. What I want to do now is I want to work on a program for you. What I've been doing each week is going over a sample program that is meant to be helpful to you to get started on your homework assignment. You are doing a guessing game, and guess what? I'm going to do a guessing game as the program I want you to, a sample program that I want to talk about and that I want you to study. I almost didn't want to do this because it's so close to the homework assignment in the sense that it's a guessing game, but Chapter 5 that my co-author wrote the case study for is a guessing game. So each of the chapters ends with a significant programming example. So the Chapter 5 case study could be a useful thing to study as well, because it's a guessing game like we're going to do here. I'm going to do a simplified guessing game, but this will help get you started. It will kind of be talking about some of the issues that are going to come up as you approach this programming assignment. So it says try to guess an even one-digit number, sets up a scanner and so forth. I haven't filled in yet how to get an answer. Well, how many different even one-digit numbers are there? Normally I ask the class, what are one-digit numbers? Even one-digit numbers, and people usually come up with 2, 4, 6, 8. And I say, are those the only even one-digit numbers? And people say, oh, I guess 2 also is an even one-digit number. How many of those are there? There are 5. So this was a minute ago I was thinking of this. There are 5 different possible values. So I'm going to ask the R to do a next int with 5 possibilities. So again, that's the question you ask, how many different possibilities. And if we were talking about what we might do on an exam, we would be saying that this is a kind of thing that makes for a good little exam problem. You'll see it in some of the sample problems if you're trying to work on them, that you've got to come up with sequences of numbers that are not like 0 to 9. There's some other kind of range of numbers. And so you often have to do some kind of an adjustment. A minute ago, the adjustment we did was we just added 1. Here, there's a little more to it. So what's the call on next int going to get us? It's going to get numbers 0, 1, 2, 3, and 4. So that's the range of numbers it'll generate. How do we turn numbers that go up by 1 into numbers that go up by 2 every time? This is one of those table tasks that we talked about in Chapter 2. We multiply by 2. We might need to throw in a constant as well. So it's back to the table technique from Chapter 2 to be able to figure out the right expression. Turns out that the times 2 is just fine. That turns the 0 through 4 into 0 through 8 with the evens. So that's going to kind of get us our even digits, we think. Let me go ahead then and compile. Yeah, we don't need that interaction stuff anymore. We'll compile. Oops, I jumped the gun a little bit. I didn't wait long enough. Let me let it run. How about if I guess 6? It didn't say anything. It's supposed to say you got it right when I get it right. If I run it again and I say 6, so I don't quite know what's going on. I could say 6 again. Doesn't say anything. This is a challenge. We kind of don't have an easy way of knowing whether the program is behaving properly. So I'm going to do something which in a way makes no sense at all. This is a guessing game. So why would you want to do what I'm about to do, which is I'm going to tell the user the answer is equal to this. Not a very good guessing game when it tells you at the beginning what the answer is. But while we're developing and debugging it, this line of code is going to be very helpful. I suggest this in your assignment write-up, that you include a line of code like this. Obviously, you're going to delete that line of code before you turn it in. So this is just to help us while we're developing the program, that we're going to kind of be warned what the answer is. So if I go ahead and compile, the answer is 2, so when I guess 6, it is supposed to not say anything. So that was kind of the right behavior. And now the right answer is 8. How about if we say 8? So let's see if it works. It says you got it right. So it lets us actually verify whether it's doing the right thing because we know what the right answer is. So that's anyway, it's a little hint, a little tip that's helpful. Well, this does just one guess, and then it sees whether the guess is right. Obviously, we want to let the person guess more than once. So what I'm going to do is introduce, I wanted to have a while loop here, and basically I'm going to initially include all of these lines of code. So let me tab to shift it over and include all of those lines of code. That's not going to be where we want to end up, but it's kind of, it lets me talk about this idea of what goes in the loop, what doesn't go in the loop. And so one of the things that you want to be thinking about is what are these, which of these things are things that you're going to want to do only once, and which are things that you're going to want to do every single time through a loop. And we're also going to want to think about what test we would use. So I mentioned an idea last time that there have been psychological experiments that find that, that people find it easier to reason about why would you stop a loop. And so in this case, why would you stop? I mean, we are taking guesses, and there's an answer involved. And so we'd stop if the answer was ever equal to the guess. That would be the reason to stop the loop, is because they got the right answer. But remember that the while loop is worded in terms of a reason to continue, not a reason to stop. So sometimes you have to switch this around in your head. And so instead of doing an equals comparison, I'll say, well, answer is not equal to guess. Remember, there's a relational operator with the exclamation mark and an equals. We read the exclamation mark as not. So not equal. Well, answer is not equal to guess. We're going to keep looping. All right, well, let's think about some of these lines of code. This, I mean, if you said this every time, this is a bit of an intro. Try to guess an even odd number, even one-digit number. And if you keep saying it, try to guess an even one-digit number, try to guess an even one-digit number, the user's going to get annoyed. We're setting up a console scanner, and we've told you that you should only do that once. We're setting up a random object, and we don't need a whole bunch of random objects. We only need one random object. This is probably the weirdest thing of all, is suppose that every time through the loop we got a new answer. I mean, you could have that be your guessing game, but it's a very different guessing game. So, the user is expecting that there's one answer and it doesn't change. So there's a whole bunch of lines of code here. I'm going to select these lines of code, including the one that I added where I tell what the answer is. And I'm going to kind of undo what I did before. I'm going to cut them from here, and I'm going to come back up here. These are all things we want to do once before the loop begins. So these are all things that belong before the loop begins. Remember, I've mentioned in JGraphs that you can use the tab key to tab lines of code to the right, and you can use the shift tab, holding down shift while you type tab to move it back the other way, to adjust indentation so that it's right. Okay, so all of that stuff we want to do before the loop begins. And then inside of the loop, what we would see is get a guess, and prompt for it, read it, see if they've got the right answer, and keep going. Well, let's try compiling, because we get an interesting result when we try to compile. Cannot find symbol guess. So what it's saying is that the variable guess is something that it's not able to see at that point in program execution. This is a really important thing to understand. I talked about this last week in last Wednesday's lecture in an example that involved an if-else. It was the change thing. There was an example where we were doing the if-else factoring. And I mentioned at the time, this is something that you're going to struggle with in your programs. If you haven't hit it yet, you're going to hit it. Believe me, this is an issue that's going to come up. And I had 2 different students in my office hours yesterday who had this problem. So this is going to come up. It is a confusing thing when it comes up. So it's important to understand. For the 2 students who came to talk to me yesterday, they didn't have a while. They had an if, but it was the same issue involved. So look, I'm declaring int guess here. And scope, what do we say about scope? The scope of that variable is the curly braces that contain it. So it's visible inside of the while loop. But look at that while loop test. Look at, just look to the left of where the curly brace is, and you'll see that, that this is not inside that scope. So one of the things you're going to have to learn to do, this comes up a lot, if-else's for program 4, and it comes up with while loops and all sorts of these constructs, that you often have to declare a variable like this outside of the construct, outside of the if-else, outside of the while. So we don't want to have int guess declared inside, we want to have it declared outside. That's how we're going to solve the scope issue. So we often have to do that. We often have to bring a variable outside to the outer scope. And now what's its scope? Well, its scope is the curly braces that contain it now, which in this case is all of main. So now this thing is going to be visible. It'll be visible here, and it'll be visible inside the while loop because we've expanded its scope. It's kind of the whole main. From here to the end of main, that variable is visible. All right, well, let's see if it compiles now. And it says variable guess might not have been initialized. Well, that's true. We didn't give it a value here, and we're asking about its value right here. So that's a problem. Often what you need to do is to give a value to a variable like this. Like a common thing we might do is set it to 0, for example, something like that. When you're setting it to an unusual value, I think that it's worth having a comment in the middle of your method. We don't really require this. We call this inline commenting. We don't really require that you do this, but I think it's a useful thing just for your own information, if nothing else, is to kind of remind yourself, look, this was a weird thing to be doing. Why was I setting guess to be this? You could say something like value that gets us into the loop. I mentioned last time that we often refer to this as priming the loop. The idea of like priming a pump. You've got to get it started, and then once you get it started, it runs fine. So this is a notion that we have, the idea of priming a loop, or just it's a value that gets you into the loop. Is a little note that I'd be writing to myself. Some of you may have been thinking, is this a value that gets me into the loop? I mean, is this a good way of priming the loop? So if I set it to 0, is it ever going to be the case that the answer is 0? And the answer is yes. 0 is an even one-digit number, right? So this is actually not a good way to prime the loop, because setting it to 0, that's one of the possible things. If it got set to 0, it would never ask for any guesses. It would assume that the user already got it right without even making any guesses. So we don't want to do that. We want to set it to some value. We could set it to 1, for example. I actually like, in a case like this, setting it to -1. That may seem odd to set it to -1. It looks weird. But actually, that's what I like about it, is that it looks weird. So that you understand, well, that's not really what guess is supposed to be. Oh, yeah, the note says we're setting it to a value that gets us into the loop. That's why we're setting it to this weird value of -1, because it gets us into the loop. I think now we're going to compile. And if I try running it, it's letting me know the answer is 0. So what if we do 2, 4, 5? Well, that was a stupid guess. We'll guess 0, and it says you got it right. So that's good. We got to the point where it told us we had it right. I added another thing in this little mini guessing game program, just to give you an example of this, that we often want to count how many times something happened. So I'm going to have a thing called num guesses, which I'm going to set to 0. We haven't made any guesses yet, but every time they make a guess, I'm going to say num guesses plus plus. I'm going to increase the number of guesses by 1. I kind of attach the plus plus to the lines of code. That's the thing I want to count. So I'm trying to count how many times did I let them make a guess. So I attach this to that line of code to know how many guesses they made. And then I can say something like this: you got it right in, and then we can have, oops, that's not what I wanted to type, num guesses. That's kind of a long line, maybe I'd break that or something, but this is a kind of a nicer version of it. The answer is 6, how about 0, 2, and then 6, and it tells me you got it right in 3 guesses. So that's kind of a nice thing to be able to do. So counting how many times things happen is a common pattern that we see. You probably would have been able to figure that out on your own, but it's not bad to include it in this sample for today, which is meant to be the model to study to get you ready for homework 5. There's a style issue. So this program works, but there's a style issue that we haven't dealt with. And it's a style issue that if you wrote it this way, it would lose you style points on homework 5. So this is, again, something to pay attention to. Write it in your notes. Remember that this is something we care about. Remember what I said at the beginning of the lecture, this example. Think about things that you want to do once before the loop begins, and think about things you want to do once after the loop is over. And those things should not be part of the loop. The loop should be the things that you want to do multiple times. And what I've done here, think about it. How many times do you want to execute that line of code? To tell them that they got it right in so many guesses. The answer is you only want to execute it once. And you want to execute it after the loop. After the loop is done, all of the different guessing. So I'm going to cut this from here, and I'm going to put it after the loop, and then I can readjust the indentation. Now we can actually, it makes more sense. And then did we need to cut this? Actually, let me put it back here because I want to kind of let you be able to see. I'm going to comment out what's here so that it'll still be kind of visible if you're kind of trying to visualize what's going on here. Do we need to test whether guess is equal to answer when we're here? And the answer is no. This is part of that reasoning about logic. We know that we would have exited the loop, so we would know that the reason that we got here is because they got it right. So we don't need a test. We don't need to say if. We don't need that if test here. That was an unnecessary test because we had not taken this line of code that belonged after the loop and put it after the loop. So this version of it with the if inside of the while loop, it would have worked. I mean, it would have behaved right, but it would have lost you style points. So this is a good thing to study too, to make sure that you understand that you've got to figure out which lines belong before, which lines belong after. Anything that's being done once before or once after should not be inside the loop, and that's something you're going to have to apply in homework 5. So you'll want to be aware of it, be thinking about it so that you do it right for your solution for homework 5, and it's one of the ways you can distinguish yourself from people who don't watch today's lecture, is make sure you get that right. Okay, I guess I could just kind of do a quick compile and run just to make sure that it's still working. And then the version that I'll post won't have the thing that tells us the answer, 0, 4, 6, 8, 2. I got it right in 5 guesses. Okay. That's that example. Be on the calendar for today. It's a good model to study for getting ready for the homework. For the rest of the time, I want to do an example this is a fun example. I'm really sad we don't have an audience because often there's a great audience reaction to some of the things that we're going to see here, and that's kind of nice it's like being in a crowd of people who are laughing at a movie. It can be more fun than watching the movie on your own. But in any event, we don't have it, so I'll just have to simulate what students might do with this example. But I wanted to mention, use this example as a way of saying that we now have the combination of while loops and pseudo-random number generation. And once you have that combination of things, indefinite looping and random, you can do simulations. And this is very powerful, so that now, kind of once we've reached this chapter 5 point, you've actually learned a lot of very useful tools that help you write some interesting programs. In particular, you can simulate things. Well, I want to simulate roulette. This is something that you would encounter at a casino. So I brought in a little picture of a roulette table. I have it here. So, you may have seen this in movies or whatever. There's a spinning wheel. They have a ball that spins around and around and around, and it lands on numbers 1 through 36. Although there's also a number 0, a special number 0. The house wins when it's a 0. Everybody loses, when it comes up as a 0. So, and in the movies, it's usually something very dramatic where somebody bets everything, on red 25, and they either win and it has a happy ending, or they lose it all and you're sad, So that's the dramatic thing, is you could win, you only have a 1 in 37 chance, not a very good chance of winning on a specific number. But a lot of people don't realize that roulette has other kinds of bets. So you can bet whether it's even or whether it's odd. You can bet whether it's in the low range of 1 to 18 or whether it's in the high range of 19 to 36. So there's lots of other bets that you could make. And here's what I want us to do. I want us to explore a betting strategy. So I'm going to say, let's assume that you have $10 at the beginning of this. I'm going to send you to the casino and have you risk $10. And I'm going to say, while you have any money left, I want you to keep betting, and I'm going to have you bet $3 every time, and I want you to bet on the high range. What that showed here, the high range, was that it comes out with something bigger than 18, something in the 19 to 36 range. That's what we call an even money bet. You win back, you get twice your money if you win. So, all right, but we first let's figure out what the spin is going to be. We got to spin the roulette wheel. Round and round and round it goes. So we want to do a next int. Well, how many different numbers are there? Well, we bet on the numbers 1 through 36, but remember there's the 0 in there, so there's actually 37 different numbers. And so this is an interesting case where using 37 is exactly what we want, because it gets us 0 through 36. So that's kind of just the right thing. So if I want to bet on the high range, I'm going to say if that spin is greater than 18, that means that it's in the high range. So again, I'm kind of thinking of not these numbers over here, but these numbers on the right-hand side, the ones that are bigger than 18. So I'm going to say if it was bigger than 18, as I said, it's what we call an even money bet. If you do win, then basically your money is assigned to your money plus your bet. That you don't lose anything, you gain. If you had bet $3, then you get the $3 back plus another 3. And otherwise, your money is reset to money minus the bet. So we either, add your bet or subtract your bet, based on how it turned out. Then how about if we do a system.out.println here, and I'm going to say that the bet was equal to, let's do a $sign. The bet was equal to bet, and the spin was equal to spin, and this is getting to be a long line of code, so maybe I'll break the line of code, and I've mentioned that we often kind of line things up with parentheses like this. So the other thing that the style guide mentions is you can indent by 8 spaces, which would be another fine thing to do. But so the bet is that, the spin is that, and now money is equal to money. So we'll kind of report to the user what they bet, what the spin turned out to be, and what their money is equal to now. I think I intended one other thing. Let me add this in. I'm going to say system.out.println initial money is equal to, I'll just kind of point out to people their $10, that you start with. So we'll tell them what their initial money is, and we'll kind of keep doing this thing. We're betting $3 at a time, spin the wheel, see if they win, and we give them updated information about their bet. So that's our while loop. We're simulating what happens if you use this betting strategy when you go to the casino. I think one of the things I like about this example, and I think you're not going to get the sense the way we normally do, is you can kind of sense because the audience is sometimes surprised by how this program behaves. And if that's true, if you're surprised by how this program behaves, then that is kind of letting you know that the simulation is doing something useful. It's letting you figure out that maybe this turns out differently than you thought. I mean, you could make your guesses about what you think is going to happen, but let's kind of see what happens when we run this. Maybe some of you think that somehow I'm onto some magic system that makes money. Believe me, it's not a magic system. You always end up losing all your money. But let's kind of see what happens. So I ran this, and what did it do? We started with $10. We lost, but then we won a little bit, and then we lost some more, and then we made a little money, and we ended up with, negative $2. That's not good. Well, what happened? We ended here with $1, and then what we did is we bet $3 the next time round. I do want to be talking about this, so we'll watch some more runs and see some more interesting things, but I want to fix that little part of it. So we don't want to let the person bet $3 if they don't have $3. This is kind of letting the person bet money they don't have. And actually what you find is if you run some more simulations is that keeps them alive long enough that they make back a lot of money. Some people think that's what they do on Wall Street is they bet money they don't really have, and it allows them to win even though they shouldn't win. So we could throw in some kind of an if here, that's something about money versus bet, that if we don't have enough money, we adjust it. And I'll include in the version I put on the calendar for today an if version of this. But I wanted to point out that sometimes when you're doing something like this, you can say to yourself, I bet this is some kind of a min-max computation. I bet you that somehow knowing the min or the max of two things would let me know what to do here. That's a good instinct, by the way. This is a min-max. I mean, I'm not saying which one it is yet, but it's one or the other. And what is it that matters? Well, what did I say would be in the if? We would be comparing $3 against money. So there's kind of the issue of we like to bet $3, but maybe there's not enough money that you could bet $3. So it's kind of how do those compare, the 3 and the money? If money is really high, then we'll bet 3. If money is below 3, then we want to bet money. Now, if you set this to math.max, what's the bigger of these two, then it'll always bet all your money. It'll always bet absolutely what you have. So we don't want to do a max. What we want to do is a min computation. So if money is 10, like it is initially, then the smaller of 3 and 10 is 3. So it's betting $3. But if we get down to a point, say, where we have only $1, it says which is smaller, 3 or 1? 1 is smaller. So this is a min computation. So we can go ahead and compile, and let's just kind of make sure that this time it's not letting us, we went to 0 here. Let's see what happened along the way. Whoa, that's kind of interesting. This went a very different way than the first time. We stayed alive a lot longer. We kind of, the betting went on a lot longer than it did initially. This is kind of the insight that you get from the basic simulation here, is that different people have these different experiences. Sometimes it's very short. Sometimes you run out of money very quickly. Other times it goes on for a while. So the other nice thing about this is it gives me the opportunity to talk about doing a max-min computation. So I want to compute, because what people often say if they come back from the casino, well, at one point I was up $75 or whatever. That's kind of a measure we want to know, is how much money you had at your peak. So I want to know what's your maximum amount of money. This is described in chapter 4, actually, that it talks about max-min computations. You're going to be doing it in homework 5. So one of the issues is figuring out what to initialize the max or the min to. So this can sometimes be tricky. But one of the easy things is if you can know what it was initially, kind of the money initially, and we do. We can kind of set max to be what money was initially. And then what we do is, as money gets updated, the way that we do a max-min computation is we throw in a test if if money is greater than the old max that we had seen before. If we have a new higher value of money than we had before, we reset max to be that. So if money has gotten bigger than what max was before, then up the max, so that it's the same thing as that value of money. And then after the loop, we can do something like system.out.println max is equal to max. So now our program is going to tell us what people tend to tell their friends, is kind of how much they were up at the end. So let's see how the simulation goes. Wow, this is the luckiest of the 3. That person was up $118. So, this person had an exciting time. Look at how long they played that game, and they only started out with $10. There's an interesting thing that economists will study. There's a belief that people who go to casinos had beginner's luck. And there's actually some reason to believe that might be true, and not because luck exists, but because, if you're the person who went here, maybe let's try running it again and see if we get one of these crappy outcomes. Oh, that's a person who was up $85. This was a person who was up 10. What if you were this person? You kind of said, I'm going to go do Stewart's strategy. You go to the casino, you lose all your money right away, and get back on the bus to go back to campus or whatever. You'd say casinos suck. Casinos are boring. You lose your money right away. So since you are not lucky, when you went to the casino, you think casinos aren't fun. These other people are going to say, oh man, casinos are exciting. You get up $85 on a $10 stake. So people have these different experiences at casinos. And, and normally the audience would be reacting to this and kind of, whoa, that you're up so much. And if it's a surprise to you, then again, what I would say is you've learned something about casinos. I've had people tell me, but this is just a program. That's not how casinos really are. It is how casinos really are. This really is a simulation of what happens. That's one of the reasons that there are people who keep going back to them and back to them. Eventually the house wins all the money, you lose everything, but you have the excitement of being up at some point in time. So it really is the case that you can have kind of an exciting experience even with a very trivial strategy like this. All right, I want to show you one last thing. We have a little over a minute to do it. What if I want to switch to the low end? So I want to kind of bet the low end. So instead of doing spin greater than 18, I'll do less than or equal to. So I'm just switching the bet, and it's an even money bet either way. So let's just kind of see what happens when we kind of run it. You were up $28, not that different than before. You were up 13, not a very good experience, up 28. That's weird. What is going on? And now I'll make a joke, how much is tuition these days? What is happening with this program? Why are these numbers going up and up and up? It has to do with the way that I redid this test. So remember that there's a 37th number, 0. And the house wins on a 0. Somebody loses on 0. I'm allowing the person to win when 0 comes up. So this is not a simulation of what it's like to go to the casino. This is a simulation of what it's like to be the casino, where you're the one that wins when a 0 comes up. This is how casinos make money, is they have a slight advantage. It's slightly more likely that they win because of that 0, and a little slight advantage of this, as long as you get people betting and betting and betting and over and over and over again, you're going to make this kind of money. So, own a casino, run a casino. This isn't a strategy of going to the casino and winning. This is a strategy of being a casino. It's helpful to be the one who is the house, and wins on the 0. I'll post something that has some extra bit in here for the test that fixes this problem, and we'll be talking more about the logic stuff in Friday's and Monday's lecture. So that's it for today.